Okay, when we're balancing this equation, we're going to do the same things. We're going to first take an atom inventory. So we have irons, we have hydrogens, and then I look here and I see this big long thing and this all the same thing. So that tells me it's an acetate. So to keep my life simple, I'm going to just put this together and count how many acetates I have total. Okay, so on the reactant side, I have one iron, one hydrogen, one acetate, and on the product side, I have one iron, three acetates, and two hydrogens. Okay, so the first thing I'm going to do is I am going to be putting a 2 in front of this. When you have problems that look kind of tricky to balance, a hint is to put a 2 in front of the one with the most number of atoms. So that would be the iron 3 acetate. So now I have 2 irons, and 2 times 3 is 6 acetates, so I have a 6 here. Okay, so now I'm going to make my irons even on the reactant side by putting a 2 in front of the irons. So now my irons are even. However, my acetates are not even because I have 6 on the products and only 1 on the reactants. So I'm going to put a 6 in front of this. So now I have 6 acetates on both sides, but that also affects my hydrogens. So now I have 6 hydrogens on the reactants and only 2 on the products. So I am going to look here and I will say, okay, if I put a 3 in front of this, now 3 times 2 is going to give me 6, and the entire equation is balanced. And now, since I did put a 2 in front, I'd want to check, can I reduce every single number? And since I can't reduce every single number, I'm just going to leave it as 2, 6, 2, 3. So the 2, 6, 2, 3.